I'm Anil Kumar. Welcome to my YouTube channel. I understand from my students that they had a CPT test for MPM2D. However, the test paper was leaked. It was on internet and many students found it before the exam date. So it was cancelled. But that gives me an opportunity to share with you some brilliant questions which are good enough for MPM2D curriculum. And let's look into their solution. So I've printed out this copy from the internet. Here is what it describes. So we have a couple of interesting questions. The video might take about half an hour. I hope that will be educational. And so please bear with me. And if you like and subscribe to my videos in between, that'd be great. So this is actually for the grade 10 students here in Toronto. The activity makes up 20% of your final grade. It's marked out of 86. The grade 10 maths took a trip to the Root of Fun theme park that was being built in the area. The park is designed to have 4 main areas: the origin of fun, the entrance area to the park, quadratics in motion, rides and games based on quadratic relations, towers or trigonometry, rides and games based on trigonometry and triangles, food equation, food court area. So that's an interesting way of making questions. Let's see what the questions are. As part of their trip, they must use their mathematical knowledge to provide assistance with the design of the park. You have been assigned the task of creating solutions to verify the calculations and information each group provides. As a result, you must carry out each of the following tasks with the people who have been assigned to them. So here is the very first task. It seems we'll have 4 tasks here. It says, as the students were approaching the park, they noticed a huge tower that was just being completed. Lucas and Jacob were part of the group responsible for looking at the advertising. They couldn't help but to think that one of the main attractions of the park would be the ride involving this tower. It was a bright sunny day. As they got off the bus, they collected the mathematical materials provided by their teacher: pencil, paper, eraser, calculator, measuring tape, a clinometer. Clinometer is a tool used for measuring vertical angles. They walked through the park until they reached the shadow of the tower. They looked up and couldn't believe how high it was. Explain. Now the question based on this is, so we have a couple of questions based on this. It says, explain how the height of the tower might be calculated from the material they have using similar triangles. You must want to sketch picture of the tower as part of your solution. Since this is just at the end of the page, I have copied this question on a separate page. So I'll share that with you. So question number 1, based on the information, is explain how the height of the tower might be calculated from the materials they have using similar triangles. Now that's question number 1. And question number 2 is also written here, which is explain how the height of the tower might be calculated using trigonometry. So let's begin with the first part, and let's say we are looking at tower and the shadow, right? Okay, let me make the sketch here. Let's say this is the tower, right? So I'm not making a very fancy drawing here. And that's the ground. So the shadow, let's say, is coming kind of like this. How can they measure the height of the tower? That means we need to figure out what is the height. And we have a measuring tape, so we can actually measure this distance, which is from shadow to the base. So we know this distance is x. We can measure this for sure. Now we need to use the concept of similar triangles first to find the height of the tower. Similar triangles means that we are looking for two triangles, correct? We do have a straw, okay? So what we can do here is we'll place the straw here somewhere. So we'll place the straw to align the shadow, right? So that the shadow of the straw matches with the tip of the shadow of the tower. So the activity here is place the straw to match the tip of the shadow. Now as soon as you do that, you have similar triangles, since this angle is common and they are 90 degrees. So we have right triangles, perfect, with a common angle. So what we have here is, let's say the length of the shadow is L, right? We can also measure this distance. So let me call this as S, the straw distance, okay, from the tip, right? So all these distances are from the tip. So from here, using similar triangles, let's call them as ABC, it will be easier, right? Okay. So from here we can say that the ratio of the triangle sides DE over AE is equal to BC over AC. The only thing which you cannot measure directly is the height of the tower. So that can now be written as product of AE with BC. Cross multiply, right? Divided by AC. So all other things can be measured. And therefore, this particular formula right there helps you to find the height of the tower using similar triangles. Is that clear to you? Perfect. So part A is done. Now let's look into the other part, which is trigonometry. So this is our part A. Now we'll look into part B. Explain how the height of the tower might be calculated using trigonometry. Now we can say that we can find the angle BAC, right? We have clinometer with us, correct? So that helps you to find the vertical angles. So we have clinometer with which we can find the angle BAC. So we know the angle BAC, we know what is the distance from A to E, and we can now need to find the opposite end, right? This is opposite side, right? And this is adjacent. This ratio is given by tan, so we know tan of, we can write angle A is DE over AE. So from here we can definitely find what DE is, and so we get a formula which gives you that DE is equal to AE times tan of angle A. So that is the second method of finding the height of the tower using trigonometry. So I hope with this the concept is clear, right? So let's move on now and answer the rest of the test paper. Now we have question number 3, which is a wooden ramp is being built to provide wheelchair access to the park. Stacy, Elias, and Kiko drew out an initial plan where the ramp would span a horizontal distance of 9 meters and vertical distance of 2.7 meters. However, they decided the ramp would need extra support. As a result, they decided to place an extra vertical support 5.5 meters from the point where the ramp meets the ground. Part A is sketch the diagram of the ramp. So that's simple. Let's do this sketching. So what we have here is okay, so that becomes the ramp. Okay. So it's a wooden ramp being built to provide wheelchair access, and it is horizontal distance is 9 meters. So that distance is 9 meters. And the vertical distance is 2.7 meters. Right? Then they say, however, they decide the ramp would need an extra support. As a result, they decide to place the extra vertical support 5.5 meters from the point where the ramp meets the ground. So let's say 5.5 meters from this particular point where it meets the ground. So that is 5.5 meters. Is that clear to you? That is the support. Right? So let's label it once. It'd be easier for us to communicate. So ABC, let's call it D and E. And these are at right angles. So that becomes the diagram for us. Now let's see other questions based on this. The question here is, use similar triangles to determine the length of the vertical support. Okay, so let's again sketch it, and let's use similar triangles to find the length of the vertical support. Okay, so I've named it differently now. However, we'll maintain the dimensions as given in the question. 9 meters was given to us, correct? And this height was 2.7 meters. And this is 5.5 from A. Use similar triangles to determine the length of the vertical, right? So we have two right triangles. We know triangle ADE in this case is similar to triangle ABC from the property A similarity. Okay? Since this angle is common angle and 90 degrees, right? So angle A equals to angle A, and we have angle B equals to angle D. Right? Both are 90 degrees. So when you have similar triangles, ratios of sides are constant, and therefore we can write, we need to find this height. Let's say this be height, h. So in that case, h over 2.7 is equal to the smaller side 5.5 over 9. So h equals to, you can just multiply 5.5 over 9 times 2.7. So let's use calculator to find this height. So we get, let's write it in decimals, 1.65. Units will be meters, right? So that is how we can figure it out, correct? So I hope that is absolutely clear. Now let's look into part C, which is use trigonometric ratios to determine the length of the vertical height. So let me do it here itself. So this is part B. Let's do part C here also. Trigonometric ratios means, again, we need to find this angle. And as we did, we know opposite and adjacent. So we know tan of A is basically equals to ratio of DE over AD. So we can write this as 2.7 over 9. And so we know angle A is tan inverse of 2.7 over 9. And which is You don't really have to find the angle, since again we'll have to use tan. So anyway, so we'll do shift tan inverse of 2.7 divided by 9, and that gives you 16.699. So 16. We can write this as 6992. Okay. Now if you look into, that was the bigger triangle. So this is in triangle ADE. Now in the smaller triangle, we know that this height is h over tan phi. So we know tan of this angle 16.6992 is basically equal to height over 5.5. Okay? So we can cross multiply and write height as 5.5 times tan of, let's say, 16.7. Correct? It is actually good to use 4 decimals to get accurate answers, since we are rounding the numbers, or we could use 16.7 also. So we get 5.5 times tan 16.7, and that gives you 1.6500. So that is good enough, which is exactly same as we got earlier. Correct? So you see how trigonometry and similar triangles go hand in hand, right? So that is how you can solve part C of this particular question. So with this we come to task 2, which is the park had initially planned to charge $8 for admission and expected to have 2,400 visitors a day. Allison and Vaughn were assigned the task of analyzing the park's admission revenues. How much revenue would the park have for one day at the current price? Okay, this is 3 marks. So the revenue is number of visitors times the admission fees, right? Okay. So we are expecting 2,400, and the admission fees is $8. So we can just multiply these two to get the answer, right? So we get 2 zeros, 8 times 4, 32, 3, 16 and 3 is 19. So we are expecting $19,200 per day. So that is dollars per day. Part B is, they have been provided with some market research that shows for every 50 cents of admission price is raised, the park will have 80 fewer visitors. How much would the park revenue be if park raised their admission price by $1? So we can again calculate the same thing. So new price will be 8 plus 1, which is 9, right? So it is in dollars, $9. So now the revenue will be, again, number of visitors times admission fees you note that the number of visitors will also decrease. It says the park will have 80 fewer visitors, right, for every 50 cents increase. Now how do we incorporate this part? We increased by $1. That was straightforward. Now $1 means 2 sets of 50s, right? So that means 2 sets of 50s, right? So that means our number of visitors is going to decrease, right? So this time the visitors will be how much? So number of visitors will be 2 times less than 80. For every 50 cents, 80 fewer, right? So we have now number of visitors as 2,400 minus 2 times 80, right? So those are the new set of visitors for the new admission fees, which is $9. Do you get the idea, right? So that is how we are going to find. So the number of visitors will be not 2400 now, it will be 160 less. So let's do this calculation. So 2400 minus 160, and then we'll multiply by 9, and what we get here is 160. Right, so it is dollars 2160 for the new price. Is that clear to you? Perfect. Now let's look into part 3 of this question, which says okay, after a few calculations, Ellison and Hannah realize the park will make more money if they raise the price of admission. However, so it's very clear they are increasing the price and they are getting more revenue. Instead of 19,200, they got 2160 with $1 raise. Perfect. So as a result, they modeled the situation with the equation R equals to 2400 minus 80x times 8 plus 0.5x, where R represents revenue from sales and X represents number of price increase, sets of 50 cents, right? What form of revenue equation? How do you know it? So, well, this is the equation which is given to us. We can write down the form here itself. We did apply a similar equation to find our answer. This will be called factored form, right? So this is factored form of equation. It says, how do you know it? So how do you know it? We are giving revenue as product of two terms. So we have, let's write here, is given as product of two terms. Correct? Which are the factors of revenue, right, in this particular polynomial expression, correct? Okay, so this part is clear. Let's move on and see what is the next question for us. It says convert this equation to standard form. So let's rewrite this equation and then we'll convert this to standard form. So we have revenue R equals to 2400 minus 80x times 8 plus 0.5x. Okay. To convert this to standard form, we just open the bracket, right? So let's multiply with 2400 first. So 2400 times 8, you can use the calculator also. Right? 8 times 4, we did this calculation earlier. 8 times 4 is 32, 19,200 minus, we have half of this, which is 1200x. Now multiplying with this, we get minus 8 times 8 is 64 x, and when you multiply this, we get minus 40 x squared. Let's rearrange, writing this first. When I multiply 2400 with 0.5, this should have been positive, right? So we'll take away 640 from 1200. So let's do it. So 1200 minus 640 equals to 560. And we have plus 19,200. So that becomes the equation standard form. Now part C is, what price should the park charge to make the most revenue? So here we have a parabola which is kind of like this, right? So we do have a maximum somewhere. You can always find this maximum using different ways. So this is, what price should the park charge to make the most revenue? So we could do either completing these squares, or we could also use the formula minus b by 2a. So let's complete the squares. So we have r equals to minus, I'll take 40 common, right? And we have x squared. This becomes minus. Let's divide 560 by 40. So 560 divided by 40 will give us 14. And we have this 19,200. So let's continue this process. X squared minus 14. Half of 14 is 7. So we'll add and subtract 7 squared, which is minus 40 times. That gives us x minus 7 whole square. And this is minus 49 plus 19,200. Let's open this bracket. So we get minus 40 x minus 7 whole square minus 49 times 40. Let's do it. It becomes positive sign, right? So we have 40 times 49, which is 1960 plus 19,200, and that gives us minus 40 x minus 7 whole square. Let's add these two. We'll add 19,200. 21160. So we get the equation in factored form, which could be graphed kind of like this, correct? Where we do have a maximum, and this maximum will occur when x is equals to 7. So say what price the park charged to make most revenue. So x equals to 7. So this point here is 7. The revenue is 21160. So the price will be, so we increased 7, x value is 7, right? So the price will be equals to 8 plus 0.5 times 7. Right? So which is 8 plus 3.5, which is in dollars $11.5, correct? So that becomes the price, correct, for maximum revenue. Now part D is what price would produce a revenue of $0, right? So let me just push this a bit, and it gives us, next part is what price produces a revenue of $0. Well, that's the formula for revenue. To get $0 clearly, what we can do here is we may not charge anything, correct? So that will be free entry, correct? In that case, the revenue is 0. Perfect. So that is how we could actually have a revenue of $0. So if you don't charge, if x is 0, then we'll get a 0, correct? So we can always say, well, this is when nothing is charged. So of course, revenue, we'll write here, is 0 if admission fees is free. So since you don't charge anything from anyone, right? So you don't really earn anything. So it's free entry, revenue will be 0. So that is how we could answer this. So let's move on and take the next question. So let's continue with the task number 3 now. It says, Brandon, Erika, and Giovanni were assigned the task of deciding upon the location of the first aid station. The location of the main area of the parks were A. Origin of fun 00, B. Quadratics in motion -76, C. Tower of trigonometry -214, and D is the food equation 58. They decide to place the first aid station at the coordinate -1, 7. Graph the park locations below. Label everything. So that's 5 marks. So let's try to graph this. Here is the graph paper provided to us. Okay, so let's begin with the 0, 0, the origin itself, which is the origin of fun. So let me mark this point 0, 0 here. Okay, so that is 0, 0, right? So we'll call this origin of fun. So we'll call this a fun area, right? Okay. Then we have minus 7, 6 as quadratics in motion. So minus 7 and 6 is this point, which we'll call as Q. Or sorry, we'll call, they were given A, B, C. So this is B for us. Okay, that is better. So this point here is A. Fine. C is the tower of trigonometry, which is minus 2, 14. So let's mark this. Minus 2 and 14, which will be up, right? So it is up to 12. Okay. So 13, 14. So maybe somewhere here, we'll just mark it here. So we'll call this as our point C. Minus 2 and 14. D is the food equation, 5, 8. So 5 and 8. These are the 4 points which we have marked. And now it is saying that they decide to place the first aid station at the coordinates minus 1, 7. So minus 1 and 7 is this coordinate. Now the question here is, well, that's first part. Let's label this as first aid. Let me write this as F, right? So we'll call this point as F for first aid. So let's move on to the next page to see what is question number 2 for us. It says, does the location of first aid station actually fall in the middle of the park? Provide mathematical calculation to support your answer, right? So how do we figure this out? Well, what we could do here is we could draw the diagonals, right? So if I connect B to D, right? And if I connect this point with A and C, for example, right? So I'm just doing an approximate diagram here. The idea here is, if I get this point right in the center of these two diagonals, then I think it is in the center. So that's the whole idea, right? So we could go with this. So basically, let's find the midpoints, right? To do it mathematically. So let's find midpoint of BD. So these are our points. We have A, which is 0, 0. Let's write down here. We have B, which is minus 7, 6. We have C, which is minus 2, 14. And then D, which is 5, 8. Correct? We kind of have a sketch which looks like this. Let me just draw it here. It makes things simpler, right? We have something like this, where these points are A, B, C, D. And we want to find the midpoint, correct? So let's find center of BD. So midpoint of BD will be average value of B and D. So B and D means minus 7 plus 5 divided by 2. And the Y value 6 plus 8 divided by 2. So that gives us, we have to verify if this is 5 and 8, right? So from here we have minus 7 and plus 5 is minus 2. And minus 2 divided by 2 is minus 1. And then this is 14 divided by 2 is 7, correct? So we get minus 1 and 7, which is the location of the first aid station. Do you see that? Minus 1 and 7. So this location we found is minus 1 and 7. But let's again find the midpoint of CA. So So it's definitely between B and D. Let's check with C and A, which is 0 plus minus 2 divided by 2, and this is 0 plus 14 divided by 2, which is again minus 1, 7, correct? So we have found that this first 8 is right in the intersection of both the diagonals. So we can conclude that it is right in the center. So we can say yes, first 8 station actually falls in the middle. Right? So it is intersection of diagonals. Perfect. Now, question number 3 is, if Erika walked from A to C and Giovanni walked from B to D, determine the equation of line of Erika's path and Giovanni's path. One equation for each. So we need to now find equation of two lines basically. So the equations are from A to C. So one equation from A to C. Okay. Let's find this. Now, as far as the points A and C is concerned, we'll write down the equations here, but let's use this particular space to find the equation, right? So we'll do solution 3. Since you cannot see most of the page here, so we'll just provide solution 3 here. So we're looking at 2 points which are A and C. So A is 0, 0, right? So that is your y-intercept. And C is minus 2, 14, right? So from here clearly we have slope M, which is 14 over minus 2, right? Which is minus 7. And since this equation goes through the origin itself, we have the equation as y equals to minus 7x. Correct? So that is how we could actually write the equation. So Erika's equation is y equals to minus 7x. The y-intercept is at the origin, right? So I hope that is clear to you. Let's find the equation from B to D now. Okay. So B to D, we are looking at these 2 points. So slope B to D is y2 minus y1, which is 8 minus 6 over 5 minus 7 will make it plus 7. So we have 2 over 12 or 1 over 6. So the equation is y equals to 1 over 6x plus b. To find the value of b, we'll put the value 5, 8 here. So 8 equals to 5 over 6 plus b. Right. So we'll do this. So b, let's do like this. So b will be equals to 8 minus 5 over 6, which is 48 minus 5 over 6, or 43 over 6. So we have the equation y equals to 1 over 6x plus 43 over 6. So 43 over 6 is close to 7, and that seems to be okay. So that seems to be okay. So we get y equals to 1 over 6x plus 43 over 6. Okay, so it does go slightly above 7, so it makes sense, correct? Just kind of a rough check. So determine the equation of these lines, so those become the equation of our lines. Perfect. So I hope that part is visible. Now, part B is, where would their path cross each other? Use substitution or elimination method. So we now have 2 equations. One is y equals to minus 7x. The other one is y equals to 1 over 6x plus 43 over 6. Right. Now we can substitute y equals to 7x in this equation. So we have equation 1 and equation 2. So we can do both methods, substitution or elimination. All right. So either way. So so let's do substitution. So we'll substitute 1 in 2. So we get minus 7x equals to 1 over 6x plus 43 over 6. So let's multiply by 6. We get minus 42x equals to x plus 43. Bringing it together, we get minus 43x equals to 43, right? So that gives you the value of x as equals to 43 over minus 43, which is definitely minus 1. And when you substitute this value of 1 here, so we get y equals to minus 7x. So y equals to minus 7 times minus 1. So y equals to plus 7. Correct? So point of intersection is minus 1, 7, correct? Which is the first stage position, right? So I hope that is absolutely clear. Now we come to task 4, which is a walking tour of park is going to be offered as an option to visitors. Shelley, Hetty and Griffin are assigned the task of determining information about the tour. They use the same coordinates as the previous question. A is 0, 0, B is minus 7, 6, C is towers of trigonometry minus 2, 14, and D, the food equation, is 5, 2. Every square of the graph equals 60 meters in the park, right? So we'll multiply by 60 the perimeter. Determine the total distance that would be traveled on to that goes from A to B to C to D and then back to A, right? So full. Provide mathematical calculations to support your answer. So we'll use simple formula here, distance formula. So distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square, correct? So first is from A to B. So let's find the distance. We'll do it in this space here, right? So from A to B, this distance is equal to basically square root of this square over that square. So that is 7 square, 6 square, right? So we can use calculator actually. So let's do square root of 7 square plus 6 square, which is square root of 85. Let me write down square root of 85 for the time being. Then we have from B to C. So absolute value will take distances. So B to C is square root of this minus this. Let's do minus 7 plus 2 whole square plus 6 minus 14 whole square, which is okay. So minus 7 plus 2 is 5 square, which is 25. So we'll do anyway, write 5 square plus within bracket 6 minus 14 whole square, and this is equal to square root of 89. Okay. Then B to C, okay, and then C to D. C to D is C to D will be square root of 5 plus 2 whole square plus 8 minus 14 whole square. Okay. So we can write this as 7 square plus within bracket 8 minus 14 whole square, and that is equal to square root of 85. Same as AB if you notice, right? Now it goes back to A, so the distance from D to A will be square root of D to A, right? 5 square plus 8 square, right? 40 and 25 plus 64. 25 plus 64 is 89. Okay. Why? So you notice that these two distances, opposite sides, have equal lengths, correct? Now it says determine the total distance, right? So we can write total distance is, add them all, right? So square root of 85 plus square root of 89. They are repeating, so we'll just do 2 times, correct? Let's figure this out. So we already have square root of 85. Let's do it again. So we'll do 2 times, and within brackets we'll write square root of 85 plus square root of 89, bracket close, equals to decimal value. We get this approximately 37.3. So that is a distance, but they are saying that they are given a scale. Every square on the graph equals 60 meters, right? So in meters, so since we have this unit here, 60 meters, right? So in meters, which is 37.3 times 60 meters, correct? So this is equal to, let's multiply this by 60. And we get this as 2238.4 meters, which is 2.238 kilometers. 2.238 kilometers. So I hope this part is absolutely clear, right? Question number 2 is, what shape is formed by the path traced in the walking tour? So what we really found here was that a couple of things. Let me just again sketch this here approximately, right? So what we notice here, that these opposite sides are equal, and we also notice that these diagonals meet at a point, right? They intersect, and that is the center point, midpoint of both, right? So this is, these are equal, right? Okay. So the shape here, since opposite sides are equal and they are parallel, or we can say that this is a parallelogram. Now, to really get to the parallelogram part of this, let's write this as ABCD. Opposite sides are equal, that we figured out. Let's find, we also found the slope of the diagonals, but let's find slope AB and CD. So slope, this is 0, 0. Point B is minus 7, 6. D is minus 214. C, and D is 5, 8. So slope from A to B is basically 7, 6 over minus 7, we can write, which is minus 6 over 7. And the slope from D to C, will be y2 minus y1, which is 14 minus 8 over minus 2 minus 5. So 14 minus 8 is 6 and minus 7. So what you notice here is that the opposite sides have same slope also, right? So they are equal. And now let's find the slope for B to C. So B to C is 14 minus 6 over minus 2 minus 7 will be this, right? So So that's what you get, which is 8 over 5. And this slope is 8 over 5. You can see that slope for A to D is basically 8 over 5, right? So they are also equal. What we notice here is that the slopes of opposite sides, we know slope of A to B is equal to slope of D to C. That means this line is parallel to the other line. And we also found that slope of B to C is slope of A to D. So this line, opposite lines are parallel. And therefore, we conclude it's a parallelogram. Okay. So that is how we can conclude. We have opposite condition 1 and 2. Opposite sides are equal in length and they are parallel. Perfect. So with this, we end the task 4. Now let's look into task number 5, which is Doug, Marilyn, and Tran must provide advice about hamburgers for the food court. So let me push this page a bit. Let's look into task 5. So there are 2. Isocelous foods and scale in wholesale. Delivery fee is $52.50 and per dollar $1.10 for each hamburger. For scale in wholesale, delivery fee is $12.30 and $1.17 for each burger. Question is, determine the cost of purchasing 200 burgers from each company, right? So let's just substitute 200 and then figure it out. So if we can write the cost C from this company I as delivery charge is fixed, which is 52.5 plus for each burger, right? So we have 1.10 times n. Here we have the cost from scaling as delivery charge is 12.30 plus 1.17 n. So that becomes the equation. To find the cost for purchasing 200 burgers, that means n equals to 200. Let's find the cost. So for CI, it will be 52.5 plus 1.10 times 200. And for this, we'll calculate this. And here it will be from the other company, it is going to be 1230 plus 1.17 times 200. Let's calculate. So we have 52.5 plus 1.1 times 200, which is the decimal value 272.50. And the other one here is 12.3 plus 1.17 times 200, which is in decimals 246.30, right? So all are in dollars. Now part B, question number 2 here is, determine the cost of purchasing 2,000. Okay, so let's figure out for 2,000 here itself. So when n is 2,000, it will be 52.5 plus 1.10 times 2,000. And this will be 1230 plus 1.17 times 2,000. Okay. So it is 52.5 plus 1.1 times 2,000, which is decimal value 2252.50. And here we get 1230 plus 1.17 times 2,000, which is in decimals 2352.30. Right. So those are the costs. Now, from here we can compare which one is better for what kind of bargain, right? So if the values are the delivery charge is pretty high. So if quantity is higher, this will be cheaper, right? So it is $100 cheaper for higher quantities. But for lower quantities, scale in wholesale is better, correct? Now let's look into question number 3 from this particular section. If cost is the main concern, describe the circumstances under which the company should be selected. Right? So that's the whole case. So we have an idea about that if it is around 2000, then the first company, isosceles food, is better. Otherwise, the other company is better. However, we need to really work out the exact value when they will give you for the same cost. So let's rework on our equations, right? So we have two equations to work. We have that isosceles is 52.5 plus 1.10n, and the scaling is 12.30 plus 1.17n. So let's find the same cost, right? So for what value of n is it same? So let's find when is Ci equals to Cs. So that is to say 52.5 plus 1.10n is equals to 12.30 plus 1.17n, right? So let's bring the n terms together. 52.5 minus 12.30 equals to 1.17n minus 1.10n. Right? Let's take it to the right side and calculate the value of n. So we have 52.5 minus 12.3, which is equal to, in decimals, 40.2. So we have equation 40.2 equals to, that becomes 0.07n. And now n is 40.2 over 0.07, that is the value of n. So we'll divide this by 0.07. So we get a number which is 574.2. Okay. So it clearly indicates that there is a point where one company is cheaper than the other based on the cost, right? So we can say that the company isosceles food better for n because it has higher fees, right? So for higher numbers it is better for n greater than 574. And the other company, which is Scalene, right? For n which is less than equal to 570. Is that clear to you? So that is how we can actually solve this particular question. So that brings us to the end of task 5. Now let's take up task 6. Now let's look into task 6, which is a section of a roller coaster track is displayed in the graph below. Right? So have a close look at this graph. And now let's find questions related to this particular parabola, which is opening downwards. Wally, Janet, and Sunhill are responsible for the roller coaster design. Label 3 important parts of the graph. That is question number 1. Okay. So when you look into this graph, I think the important parts here are this point A. Well, let's call this as A. The vertex, of course, is very important. Now that point also is extremely important. The x-intercept is not very critical. Is normally a critical point, but here it is not well defined. So the other point which we could use is a very perfect number D, which is a clear point to look into, right? Coordinates of point A are 6, 9. So let me write this as 6, 9. Coordinates of point B are 7, 11. Coordinates of point C are 8, 9. And we'll use the D as a checkpoint. So we have to give only 3, so those 3 are sufficient. Okay. However, this checkpoint will be 9, 3. Okay. So anyway, label 3 points. So we labeled 3 points as A, which is 6, 9. And then we have B, which is 7, 11. And we also have C, which is 8, 9. Write the equation of the graph that would model the roller coaster track displayed in the diagram. Use vertex form. Okay, so let me write it here itself using this vertex form. We have space to write. So vertex form will be y equals to a times x minus p whole square plus q, right? Where PQ is the vertex, 7, 11 in this case, so we get y equals to a times x minus 7 whole square plus 11. To get the value of a, we can substitute one of these points, right? So we have here 6 and 9, so we can write this as 9 equals to a 6 minus 7 whole square plus 11. Well, you'll also notice one thing, and that is, if you move one step to the right, you're moving 2 steps down, right? That means A should be 2, right? So that gives you an idea about the value of A, correct? Anyway, let's verify with calculations. Bringing this to the side, we get 9 minus 11 equals to A, and that is 1, correct? So we get minus 2 as the value of A. Is going downwards, it makes sense. So the parabola will be y equals to minus 2 x minus p whole, let me rewrite this. Y equals to minus 2 x minus 7 whole square plus 11, correct? So that becomes the equation of our parabola. So using vertex form, let me write down this equation here, which is y equals to minus 2 x minus 7 whole square plus 11. Okay. Now part C is, the first part of the track is not displayed in the diagram. They plan on using this equation, minus x square plus 3x plus 18. Convert the equation in factored form, which is that form, correct? So let's do solution of 3 here also. So I'll provide the solution in different ink. Let's write down here, solution of 3. So we are given the equation y equals to minus x squared plus 3x plus 18. So let me first factor this minus out. So we have x squared minus 3x minus 18. We're looking for sum and product, right? So 18 is 6 times 3, that works, and 6 has to be negative. So we get x minus 6 times x plus 3. So that gives you the factored form of this particular equation. So I hope that makes sense. So in this case, P and Q are 6 and minus 3 respectively. So we can write it down here that P equals to P equals to 6, Q equals to minus 3, and A equals to minus 1, correct? So that is how we can answer the last question. So with this, we come to an end of this CPT unfortunate paper, which could not be credited since many students could see it before the test, right? But I hope you learn how everything comes together and we can actually apply our learnings in practical situations, right? So this is extremely important exercise, and that's the reason why I'm sharing with all of you, and I hope students worldwide will definitely benefit from this. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.